Okay, so what we're going to talk about today is literally going to be review pretty much of chapter 2. So that's kind of good news to some extent, except obviously there are going to be its differences. So you might be wondering, well, then why are we talking about this if it's kind of review of chapter 2? And I shouldn't say review of chapter 2. You'll see that the process that we're going to go in approaching these problems is similar to chapter 2, and the main reason why I'm saying that is it's kind of like we're repeating the same process over and over and over. And that's in fact what trig is, to be honest with you. It's very repetitive. There's actually two goals here. So we're going to say the goals of this section are, one of them is to find the exact values of trig functions given an angle or a point on terminal side. So notice how this should sound familiar to you, right? Because if you think about it in chapter 2, that's literally what we did. We found the exact values of trig functions. Either we were given the angle or we were given the point on the terminal side, which in both scenarios we had to find x, y, and r to be able to answer that question. Now the second thing we're going to do is we're going to find the angle that corresponds to the given exact value of the trig function. So for this one, you can see that we're going backwards, right? Because now I give you the exact value, and we're asked to find the angle that produces that exact value. And if you think about it, that's one of the last things we did in chapter 2. So let's actually comment on that, which I just want to kind of put this in our notes, even though I've said it, is that these concepts are or these concepts were seen in chapter 2. Okay, so the main idea here is now we will now do the same thing as chapter 2, but the information will be in radian measure. So if you think about it, yeah, we're doing the same thing as chapter 2, except in chapter 2 everything was given in radian measure, or in degree measure, where now we're going to be dealing in radian measure. So since we know that how to do these things using the ideas of chapter 2, let's jump into our first example. Find the exact values of the 6 trig functions given the value of t. And maybe you want to watch me do A, and then you can pause the video and do B by yourself, and then press play and see how yours fared compared to mine. Okay, so let's look at A. So T is representing our angle, right? Because this is our radian measure. So what we're going to do is, just like last chapter, we want to first draw this angle in standard position. And if you remember, in last section or a couple sections ago, I told you that when we see this, we know the reference angle by looking at this. This has a reference angle of 30 degrees, and since 11 pi over 6 is very close to 12 pi over 6, which 12 pi over 6 is a little bigger than 11 pi over 6, 12 pi over 6 is what? It's 2 pi, isn't it? So 11 pi over 6 comes up just a little short of 2 pi. So that's our angle 11 pi over 6. And we know that this has a reference angle of 30 degrees. And now I could draw my triangle, 30, 60, 90. And if you remember, we're not asked to use the unit circle here, so we can choose whatever we want. So I'm going to choose the shortest leg, which is opposite 30. I'll call that -1. Remember, it's negative because I'm going down. And then our x would be rad 3, and then the hypotenuse would be 2. So once we have the x, y, and r, now we could basically answer this question. So sine of 11 pi over 6 would be y over r, so it's -1/2. Its reciprocal, which is cosecant of 11 pi over 6, which would be r over y, which would be -2. Excuse me. And then we have cosine of 11 pi over 6, which is x over r. That's rad 3 over 2. We have secant of 11 pi over 6, which is 2 over rad 3. And if we want to rationalize this, it would be 2 rad 3 over 3. Okay, and then we have tangent of 11 pi over 6, which is y over x, which is -1 over rad 3, -1 over rad 3, which is negative rad 3 over 3. And finally, we have cotangent of 11 pi over 6, which cotangent of 11 pi over 6 is going to be x over y. So it's rad 3 over -1, which is negative rad 3. Okay, so doing the same thing for part B. I mean, nothing really changes. Except what do we know about 3 pi over 2? That's a quadrantal, right? Because remember, the whole number pi or half number pi, those are the quadrantals. So where would 3 pi over 2 be? This is pi over 2, 2 pi over 2, which is pi, 3 pi over 2. So that's 3 pi over 2. And if you remember, we can't write, or we can't create a right triangle. So, but finding the point on the terminal side for this one is easy, because that point would be 0, -1. So now we could answer the question. So sine of 3 pi over 2 is y. So y is -1. Also r is 1, right? Because remember, that length is 1. So x is 0, y is -1, and r is +1. So sine is y over r, so it's -1. Cosine of 3 pi over 2, that's x over r, so 0 over 1, which is 0. Cosecant of 3 pi over 2 is r over y, which is -1 again. Secant of 3 pi over 2, and here's where we run into our first problem, because what is that? That's r over x, and when we divide by 0, this is undefined. So this is actually important. We will talk about some of the domain values of trig functions, and we could see that some of them are undefined. So we'll get into that in greater detail. So tangent of 3 pi over 2, that's y over x, and remember, y is -1 over 0. And once again, this is also undefined. And then lastly, cotangent of 3 pi over 2, which is x over y, which is 0 over -1, which is 0. Okay, so with that said, now let's go ahead and find the domain values of our trig functions. So the domains of trig functions. So these are basically the domain values. If you're thinking about it, those are the values in which our trig functions won't be undefined, right? That's what we care for. Now, next chapter we will be graphing these trig functions, so it's important for us to know the domain values of these trig functions. So with that said, let's get started with this. So the domain of any function consists of all inputs in which the function produces an output. And what we mean by it produces an output, in other words, we're saying it isn't undefined. Okay, so let's start with break up with certain trig functions. So we're going to talk about for sine and cosine. And you'll see why I'm grouping them together, because we know that we could say, look, notice that sine and cosine are defined as, we know that sine of t is y over r, and cosine of t is x over r. And I'm going to turn my attention to r, and so notice what we're going to say is the only way, and in fact you should be able to answer this question, what's the only way sine and cosine will be undefined, is if r itself is 0. And we can make a comment on that. So the only way sine cosine will be undefined is if r equals to 0. But what is it that we know? However, r is always a positive number. Thus, since r will never be 0, so if r will never be 0, what does that mean about sine and cosine? Sine and cosine will never be undefined. So if it'll never be 0, then sine cosine will never be undefined. Will never be undefined. So what does that mean? Their domain is going to be all real numbers. So their domain is all real numbers. Which is written as t is in, if you've seen this notation, what are we saying? T can be any real number. So don't ever expect sine or cosine to be undefined, okay, because they won't be. So let's now talk about tangent and secant. For tangent and secant, let's talk about what they're defined as. And we know that they're defined as tangent of t is y over x, and secant of t is r over x. So notice how I'm grouping them on purpose like this, because they both have x in the denominator, and we know that they will be undefined, so these will be undefined when x equals to 0. And we know that x equals to 0 when we have certain angles. So we could say, look, notice that x equals 0 when t equals to pi over 2, 3 pi over 2, 5 pi over 2, and so on. And if we look at it graphically, if I were to graph my angles, where would x be 0? X would be 0 when I land up there, because what are the coordinates of that point? 0, 1. Or x would be 0 when I landed down here, which is 3 pi over 2, which is 0, negative 1. So notice how that's pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. Now what do you notice? Every time that I go from one to the other, I keep adding pi. So what is it that I want the domain of tangent and secant to be? All real numbers except for when you land on the y-axis. And we have a formula for writing that. So we're going to say, so their domain is all real number except t can't equal to pi over 2 plus pi k. And k is an integer. Right, that's an integer. So that's basically how we get to that. So let's do the same for the last two. For cotangent and cosecant, we're going to use the same idea. What is it that we know? These are defined as cotangent of t is x over y, and cosecant of t is r over y. And what do we know? These will be undefined when y is 0. So these will be undefined when y equals 0. So when does y equal to 0? Notice y equals 0 when t equals 0, pi, 2 pi, and so on, which means where do we land? We land here or here, right? That's 0, pi, 2 pi, 3 pi, if I keep going around, right? So it's 0 or 1, 0, negative 1, 0. You could see how the y values are 0 here. Okay, so what is it that we know? So their domain is all real numbers except t can't equal to pi k. And once again, k has to be an integer. Okay, so, and when we graph these, you'll see how that will work out the way it does. All right, so let's move on to our next two examples, and that'll take care of this section. So for example 2, this one is, instead of given the angle, we're going to be given the point. So given negative 7 over 25 and 24 over 25 is a point on the unit circle corresponding to a real number t, find the value of the 6 trig functions. Six trig functions of t. Okay, so here's the good news. The good news is I have x, y, and r. See, that's x, that's y, and I already know what r is because they told us that it's on a unit circle. So if it's on a unit circle, the r is 1. So we would get r is 1, right? Because we were told that it's a unit circle. So with that said, since I have x, y, and r, there's really no picture I really need to draw, right? So sine of t is what? Y over r. So it'll be 24 over 25 over negative 1, or sorry, r can't be negative 1. R is always positive, sorry about that. I keep mentioning how it has to be a positive number, and here I am writing it as a negative 1. But anyway, going back to this, 24 over 25 divided by 1 is just 24 over 25. And then cosecant of t is just the reciprocal of this, which would be 25 over 24. And then what else do we have? We have cosine of t, which is x over r, so negative 7 over 25 over 1, which is negative 7 over 25. And then we have its reciprocal, secant of t, which is negative 25 over 7. And then we have tangent of t, which is what? Y over x, so it's negative 7 over 25, or other way around, 24 over 25 over negative 7 over 25. And if I simplify this, I have to multiply by a reciprocal of the denominator, and the 25's cancel out, and we get negative 24 over 7. And cotangent of t is just literally the reciprocal of negative 24 over 7, which will be negative 7 over 24. And there you have it. So let's move on to example 3. And for example 3, now we're going to work backwards. So we're saying find the value of t that corresponds to the given function value. So if you think about it, now we're going to be given the exact value and we're asked to find the angle. So cosine of t is negative rad 2 over 2. T is in quadrant 2. And then for b, we're going to have tangent of t is rad 3, where t is in quadrant 3. So once again, we'll do A together and then you can pause the video and do B on your own. But let's kind of talk about this. Let's review this real quick. So when asked, so what we're going to say is this. When asked, and I guess I'll do it step by step along with this, just so you see it. So hopefully this isn't anything new to you, except our angles are going to be given in radian now. So when asked to find the angle that corresponds to a given value, we're going to do this. 1, identify x, y, and r. So if I look at this, cosine by definition is what? X over r. So x is negative rad 2, r is 2. How do I find y? I use the Pythagorean Theorem, right? So we have negative rad 2 squared plus y squared equals to 2 squared, right? It's just x squared plus y squared equals r squared, which becomes 2 plus y squared equals 4. And then we would subtract, we get y squared is 2, y is plus or minus rad 2. Okay, so now that, let me move this up. So since y is plus or minus rad 2, we need to figure out which one we take. Well, if you look at what I said earlier, what is it that we said? T is in quadrant 2, and if you're in quadrant 2, which is here, your y values are positive, so we're going to take the positive rad 2. So y is rad 2. Okay? And then the second step is what? Once we identify x, y, and r, we're going to construct the angle in standard position with x, y, and r, or x, y from step 1 on the terminal side. So the xy that we found, that's the point that your terminal side goes through. So what we're basically saying is this. We have x is negative rad 2, y is positive rad 2. So that point we're talking about is here. So that's my terminal side. Okay? And then step 3, I'm going to use the same picture. Make a right triangle and identify the reference angle, which, if you see, this is negative rad 2, 2, which that's a 45, 45, 90 triangle. So this is 45. And then we state the angle or angles. Sometimes we might have more than one angle, okay? But in this case, we only have one, as you could see. So the angle I want is that one. And I'm going to give it in radians. I mean, we could find this in degrees as well, but we know it's in radians, and we know that this has to be, since it has a reference angle, it has to be some number pi over 4. Now, what is that number? See, notice how this angle comes up very close to pi, but it's just short of pi. So what would be pi as a denominator of 4? Wouldn't it be 4 pi over 4? So this comes up just short of 4 pi over 4, which means it must be 3 pi over 4. And that's my angle. Okay, so take a minute, try to do it for a tangent of t is equal to rad 3, and then press play on the video once you do it. So I'm going to go ahead and talk about this. So what was the first thing we did? We identified x, y, and r. So we know that this doesn't have a fraction, so we'll put it over 1. So we know that y is rad 3, x is 1. Now let's be careful though, because or what could y be? Y could be negative rad 3, x could be negative 1, because negative rad 3 over negative 1 is still rad 3. So notice how this is telling us that we're in quadrant 3, and if you're in quadrant 3, 1, 2, 3, what do you notice about your x's and y's? They're both negative. So it's actually this one, not that one. Okay, that would be the case if we were in quadrant 1. So we know that x is negative 1, y is negative rad 3. If you use the Pythagorean Theorem, negative 1 plus negative rad 3 squared equals r squared. We get 1 plus 3 equals to r squared. And we could see that r squared is 4, which means r equals to 2. So my x, y, and r is negative rad 3, negative 1, 2. What was the next thing we did? We drew our terminal side, or my angle and my angle in standard position. So negative 1, negative rad 3, that's the point that my terminal side goes through. So here we have it. And then what do we say? Make a right triangle. Negative 1, negative rad 3, 2. Identify then the reference angle, which notice how 1 rad 3, 2, this is a 30, 60, 90 triangle. And so notice how this is the shortest leg. So that's 30, which means my reference angle has to be 60. And then once I find that, now I want to find this angle. And here's what I know. This angle, since it has a reference angle of 60, it has to be a number pi over 3. That's the form it has to be. Now notice how this angle is a little bigger than pi, right? Because pi would stop here, but this goes past pi. So what would this number have to be for this to be pi? It would be 3 pi over 3, which is pi. So since this is a little bigger than 3 pi over 3, this would be 4 pi over 3. And there you have it. So notice how first we were given some information. We were given the angle, or we were given the point on the terminal side. We found the exact values. And then lastly, we were given the exact values, and we went backwards and said, this is what the angle has to be. Okay, so that takes care of this section. Hopefully you found it pretty much more or less a review other than the radiant stuff. But as always, don't hesitate to reach out to me if you have any questions.